you so much, Mr. Hamish. Thank you, and wish you all the best with your hard work. And I just want to say we appreciate you, and I have achieved like 93%. Sanbonani. This is Emma Onokula Wamkizismongo. I live in Devon in KwaZulu-Natal, and I was born in Kwahlabisa in KwaZulu-Natal.
Hello, how you doing? I'm Hamish. Let's get started. So if you FaceTime here, make sure you go to our page, and thanks a lot for all people donated. We need donation. Thanks so much for your donation. Means a lot, because with all this program going, means with your donation helping to make this project go. Let's get started. So now first and foremost, let's say use MACLAURIN series to expand. This one right here. So this is easy. So first and foremost, you write your formula for MACLAURIN series. So MACLAURIN series, this is what you need to know. Just memorize this. You know what I'm saying? X and then over 1 factorial, just 1 plus. So you say F, and then excuse me, this is 0 here. And then you go second derivative of X, 0, and then power 2, and then over, and then you can just go on like that, and then X cubed over 3 factorial, etc. So we need to get these, means I can get f of x, f of 0 if I don't have f of x. Same with all of it. So I'm going to start to say, let me find f of x. What of my f of x is given, which is x ln 1 plus sine of x. So this side here means I want to get f of 0, because I couldn't get f of 0 if I don't have f of x. So I'm going to take 0 and then substitute there. So f of 0, let me just color quick. So f of 0 equal f0 equal to f of 0 equal, so here is going to be 0, 0 times anything 0, so just 0, because 0 times ln of 1 plus sine of 0. So 0 times anything equal to 0. So now I want to get f of phase derivative first before I get f of phase derivative of 0. So f of phase derivative means I have to derivate this, but this is the product rule. Means since this is a product, means I have to. We know from product rule, we say we always say, okay, I'm gonna write here. Okay, if you have u times v, we keep the first one constant, and then we differentiate the second one, and then we plus. Now v is going to be constant, and then we differentiate this constant, differentiate this, and then plus this constant, and then differentiate the first one. Product rule, because there's a product of two functions, this function and that function. So I'm going to keep the first one constant, and then I will differentiate this. So when you differentiate ln, look, if I differentiate ln of 1 plus sine of x, this is easy. What you do, differentiate whatever is in front of the ln, like let's say this is f of x. So I'll differentiate this, which is going to give me f prime, and then right under everything. You know what I'm saying? So right under your function, take this, whatever is in front of the ln, differentiate right on top, and then write everything underneath. So now, so for this case here, I'm going to say this is constants like a u, and then let's differentiate this. Means I'm going to differentiate whatever is in front of the ln. So I'll say dx of 1 plus sine x, and all this over our function, which is 1 sine of x. You know what I'm saying? And then I'll say plus. Now these are constant. Now this is going to be constant now. Ln of 1 plus sine x is constant, and now I'm going to differentiate x. When you differentiate x, I get 1. So now when you simplify this, look, when you differentiate 1, you get 0. When you differentiate sine, you get cos of x over 1 plus sine of x. Now outside here we have x, and the plus ln of 1 plus sine of x. So this is f1 prime. You know what I'm saying? So now we want to get f phase prime or 0, because we need to get that. So f times 0 equal means, remember this is like, look, this is like x, this is cos of x, 0 plus cos of times x is going to be x cos of x over 1 plus sin of x plus ln 1 plus sin of x. So this is f face prime. Like this is f face prime, so I could have written here. So we want to get f face prime of 0. We need to get there. So if I put 0 here, it's going to be 0 times anything is 0. So this is going to be 0 because 0 times cos of x because x. Okay, so we're going to say, look, f of 0 equal to f of 0 means x equal to 0. 0 times anything is 0. So on top we have 0 over 1 plus sin of 0 equal to 0. So here you get 0 plus. Now ln of 1 plus sin of 0 equal to 0. So it's ln of 1 because it's going to be 0 plus ln of 1. So 0 plus ln of 1. Ln of 1 always equal to 0. Plug in the calculator, you're going to get 0. Oh, so everything is going to be 0 plus ln of 1, which is going to be everything 0. You know what I'm saying? So in your solution, we could have needed this. I mean, this is the face prime of x. So show in your exam, make sure you show this method, you know how you got your stuff. So since I need a space, so I'm gonna erase. So I can just say my f prime equal to that. So in the exam, write everything, but here because there's space, so I'm not gonna write all the stuff here. Okay? Excuse me. Okay, so now I'm saying f face prime equal to x cos x over 1 plus sin x plus ln 1 plus sin. But f of face prime equal to, we get equal to 0, which equal to 0. So, excuse me, so now let's go for f of second prime. F of second prime. Okay, so what I'm going to do, I'll take the face prime and then differentiate to get the second prime. Means you want to get this. Okay, so I'm going to say now, second prime means we have to differentiate, but this is a quotient here, is division. You know, so I'll do it aside, but in exam, make sure you show everything. So now let me start. So this, let me say, okay, so this I'm going to write later my finance. Okay, so now let me take here, so I'm going to do my work and then write back. So f of face prime equal to x cos of x, and then we have a 1 plus sin of x, and then now we have a ln 1 plus sin of x. Okay, now let's go. So what I want to do, this is a quotient here. So we know quotient means division. If I have a dx, we want to derivate u over v. So how we derivate? We always put the denominator constant always, and then we differentiate the numerator, and then you minus. Now the second step, you must start with the denominator constant. Now the second step, numerator is constant, and then differentiate the denominator, and then you over, and then you square the denominator. You know what I'm saying? This is a formula for quotient rule. So for that case, make sure you show all this stuff in your exam or text or whatever you do. So for that case, I'm going to say, okay, now let's go. So I'm going to say now, f of second prime, because I'm differentiating this. So what is f of second prime? Equal, so denominator constant for x, 1 plus sin of x. And then I'll denominator constant, then I'll differentiate the numerator. So when you differentiate the numerator, means this, numerator itself is product rule. So let's differentiate product. So for product rule, the face one I can keep it constant, and then when you differentiate cos of x, you get negative sign. Negative sign from the differentiation rule. Go to derivative rule. Now, and then we're gonna plus. You know what happened now? Now this is gonna be constant cos of x, and then we differentiate x. When constant cos of x is constant, when you differentiate x, you get 1. Oh, so just say 1 times 1. Okay, so this denominator, excuse me, this is constant, and then we differentiate this. And then what happened? We're gonna minus. Now this step now, this is gonna be constant now. So x cos of x is cos, and then we differentiate the denominator. When you differentiate 1, you get 0. When you differentiate sine, you get cos. You get cos of x. So cos times cos is cos square x. So you can say cos square x. Okay, so you say cos square x. So then you end up get cos square x, and then you over, since is the quotient, because you must square the denominator. So you 1 plus sine of x, what? Square. So what are we gonna do now? So when you finish, right? So this is for here, okay? So you finish that, but this is for here. Remember. So after we have to differentiate also that. So we're gonna say here plus, you just a plus. Okay, you just a plus. Now we go. Plus is a plus. Now let's come and differentiate this. So when you differentiate this, you know ln of a function, differentiate your function, and then over exactly the same function. It's like find f of derivative of this function, and then we over exactly the same function. That's how we differentiate ln of a function. So now we're going to say if I differentiate ln of 1 plus sine of x, what I'm going to get, differentiate all of this function here, which is going to give you, when you differentiate 1, you get, so you say you differentiate 1 plus sine of x over 1 plus sine of x. So this is going to give us, when you differentiate 1, you get 0, sine of x, you get cos of x. So on top here, I'm going to have a cos of x over, now write 1 plus sine of x. You know what I'm saying? So when you derive a second derivative of all this function here, it's going to give us this stuff. But now we need to get f of second derivative of 0. Now let's plug 0. Look, 1 sine of x, sine of 0, because x will be equal to 0. Sine of 0 equal to 0, so 1 plus 0 equal to 0. So here you have a 0. Excuse me, sorry, it's 1, sorry. 1 plus 0, because sine of 0 equal to 0, so 1 plus 0 equal to 1. Now come here. X is 0. 0 times anything is 0. So this is going to give us 0 plus cos of 0. Cos of 0 equal to 1, 1. So it's like 1 times 1. These two, they're going to give us 1. Okay, so this and this is going to give us 1, and then we minus x. X is 0. 0 times anything equal to 0. So minus 0. So we go out here. Okay, we over 1 plus. Okay, so all this stuff 1 minus equal to 1. Okay, now we come here 1. Sine of x equal to 0. Sine of 0 because x equals 0. Sine of 0 plug in the calculator. Sine of 0 equal to 0. So 1 plus 0 is 0. 1 plus, come on now, grade 1. 1 plus 0 is 1. Square equal to 1. Now we plus here. Cos of 0 equal to 1. And then we over, this will be 1. Sine of 0 equal to 0. So 1 plus 0 equal to 1. So 1 minus 0 is 1. Over 1, 1. Plus 1 equal to 2. So now f second derivative of 0 equal to 2. Oh, okay. So we have that equal to 2. You know what I'm saying? So this one now, we know this f of derivative of 0 equal to 0. So this equal to 0. And this equal to also 0. Equal to 0. But this equal to 2. So now, but you gotta show all these works, okay? So now I can say here, because I want to have a space. So we know when you take this, when you find the second derivative of this, means the second derivative, we got this one here. So you need to write in front of it, because we want to have a look, okay? That's right, nice. But make sure you show all your works, eh? How you go to stop, guys? That's how you get a marks. Everything, make sure you show in an exam or in a test or whatever you're doing. Okay, cool. So I'm going to say now my second derivative equal to 1 plus sine of x. Sine of x, and then negative x sine of x, and then plus cos of x. Okay, and then minus x cos square x, and then we over. Okay, we over 1 plus sine of x, and then plus cos of x over 1 plus sine of x. This is second derivative, okay? But you need to show how the answer comes. And then here also, we're gonna say just like how we say here, f of second derivative of 0 now equal to 2 we got. Okay, so you don't want to go like a lot of them, just some. You can go one more if you want, but I think for now it's fine. Okay, cool. So now let's finish up our question. Excuse me. Just a second, guys. Okay, let me just wipe a little bit and then we'll finish this. Okay, my white one was getting dead, so I'm trying to. Okay, cool. So now, what I'm gonna do now is substitute it back. So now our MACLAURIN series equal to f of 0. What is f of 0? We say 0. We got it 0. And then f of first prime equal to 0. So 0 times x over 1 factorial. But 1 factorial, if you plug in the calculator, equal to 1. But let's write 1 factorial for so long, and then we plus. Now, because they say here stop at in terms of x squared. So I don't even need that. You know what I'm saying? I know here I'm going to stop. It's going to give me in terms of x squared. Now, second derivative we know equal 2. This equal 2. And then times x squared. And then over our 2 factorial. So now let me finish. 0 is 0. Okay, now 0 times anything 0 over whatever we have. Because 1 factorial equal to 1. So 0 is just 0. I don't have to write. 0 times x is 0 over 1, 0. So 0 plus 0 is 0. So now you have a 2 factorial. So look, 2 over 2 factorial x squared. 2 divided by 2 factorial. 2 factorial, if you plug in the calculator, is going to give you a 2. Because 2 factorial means 2 times 1. 3 factorial means 3 times 2 times 1. But you can plug in the calculator. So this is going to give us 1x squared. So final answer equal to x squared. So if you use the MACLAURIN series, you get x squared. So finally, by MACLAURIN series, this is going to give me what? X squared. But it's all depends sometime, you know, it's not necessarily must come in. X squared depends how you're going to calculate it. Maybe here, I'm just saying, if it was, for example, this is a final answer here. But for example, let's say it was 2 over 4 factorial. Let's say x squared. So how would you do? We was going to say 2 over 4 factorial means 4 times 3 times 2. And they have x squared. So this is going to give us 2 and 2 cancel. So 1 over 12 x squared. You know what I'm saying? So depend on the equation. But for this case, it just came x squared. So look, if you face time, you know, thanks a lot for your time. And easy, man. Peace. Hello, how you doing, man? I'm Hamish. First and foremost, I want to say thank you so much for the people, you know, who donated to the program, because as you know, it's a lot of things, you know, behind, you know, deal with the you know, feeding homeless, you know, with a little half. You know, I was one of those. I was one of the homeless people for almost 4 years. You know what I'm saying? So I started this program with the knowledge, a program giving back, and you know, for most of the donation that I get from you guys, you know, it's helping us to make this project going, and you know, also go and give back to people who are in need, and also some helping this project going. You know what I'm saying? So you also can make it. It doesn't matter, you know, which background you come from. Either you come from very complex or concrete, or very tough, you can also make. I was one of those kids, you know, go to school with no shoes. Thank you so much. Thanks. It's just a waste of time. You do this question, and it's easy like that, man. Thanks a lot. You know what I'm saying? Look, man, I believe in learning from how to do things. If it's time, make sure you subscribe, and you know, you can just go and do donation to our Patreon page. I have a Patreon, I have a GoFundMe. You know what I'm saying? I have all the means of donation, because to make this project going, you know, any type of donation, the little that you think is too small for you, it could make a lot of change. And thanks a lot for all your time. You know, subscribe, don't forget, share this video, circulate to a lot of people, you know, because the meaning of this project, this program, is to help as many as we can. Okay, it's not only for one person or two, because you might think it's not helpful for you, but for somebody next out there, it could be very, very helpful. So thanks a lot, man. And you know, any donation that you did to me, it means so much. I appreciate, man. It means a lot. Go to our Patreon page, go to our GoFundMe, because we need to have a lot of things. We need to put them together, like camera, and a lot of equipment, so that we can improve on a lot of angles, a lot of aspects of these projects. Thanks a lot, man. I appreciate and I love you. Peace and bye. This is one of my students of knowledge. She wanted to introduce herself. What's your name? Could you please introduce yourself?
My name is Kali. I
Yeah.
go to Southern Primary School.
Yeah, China Wabantu. China Wabantu is everywhere, right? So this is my other student. His name, what's your name? Matthew, yeah, he's grade 11, man. So his aim is to score distinction, right? So you promise I want you to score distinction this time. And what's your name?
Joshua.
Joshua, how much you promise me to score this time?
Distinction.
Distinction. Yeah, so China Wabantu is everywhere, man.
China Wabantu. Everywhere. China Wabantu everywhere.
Everywhere.
China Wabantu
Exactly.
everywhere.
Thanks a lot, man. Appreciate it. Thanks so much. If you had to give advice, which advice would you give to the people or to the students?
Trust Amish.
Why would they trust me?
No, because it's really good. They actually has helped a lot. I redid first year for maths. It was my own fault, but also I didn't know a lot of the work. And Amish said lots of hard questions, and it's demotivating sometimes to do the harder stuff. You just want to get done, but it's the hard stuff that makes you realize the easy stuff is easy.
Abungazi zole